All right. So, meet my dog, Emma. She
Okay.
always siplat kag mata. Sige rin nagpasiplat. Madlungon. Paraygon pero sipat. All right. So last time, welcome again. We're almost done. I can't believe this. I can't believe that we are now on week 5. Woohoo! 2 more to go. And then we should eat ice cream, all of us.
Yeah, seriously.
Yeah. All right. So I mentioned last time that I'm going to cover the ANCOVA, which is analysis of covariance. But again, as I've mentioned in the very beginning of this quarter, that there are so many similarities. And when you think about ANCOVA, it's really just the regressions again. And it could be the model that we use in logistic regression, because in logistic regression we have a dependent variable that's binary, and but in other linear logistic regression and other models, it's pretty much we are trying to control for the confounders or covariates. And so in multiple linear regression, this is really what ANCOVA is all about when it comes to what's its equivalent on the ANOVA side, because ANCOVA builds from ANOVA. So you will see when we do our SPSS after the quick 24 slides that the function that we use in the SPSS, it's the same. It's a univariate function. It's the general linear model. So it's GLM. So if you look at our syllabus, it really says there that general linear modeling um, can really use as your association model as well as your predictive model, and that they are in the same family as ANOVA and regressions. They are all in that family of general linear modeling. So let's start. Again, it's what is ANCOVA? So the word an is analysis, AN means analysis, and then it gets the name COVA because of covariance. So ANOVA is analysis of variance, but now we're calling it ANCOVA because it's analysis of covariance. This is very similar to ANOVA. It builds from ANOVA, that and it assesses the differences in the mean. So it's still you again because it's within the these are what we call developmental concepts that from ANOVA you build on that one, and then you can create analysis from ANOVA, and then you can do an ANCOVA. In ANCOVA, we assess the differences in the mean of a dependent variable among different groups defined by one or more independent variables or factors. This definition is exactly the same definition that you see in multiple linear regression. That's the way how multiple linear regressions that uses the maximum likelihood mathematics or equation that has different iterations. So these are very similar procedures or analytical procedures, and it's very important that we connect the dots, that these are really it's really up to you, the researcher, of which one do you want to use. Do you want to use the ANOVA modeling, or do you want to use the regression modeling? So unlike ANOVA, ANCOVA also controls for the effect of other continuous variables, and they are called the covariates, that might influence the relationship between the dependent variable and the independent variable, so the DV and the IV. We don't do ANCOVA if we don't see a correlation. So that's a prerequisite in ANCOVA, all right? So before we even go to think that, what about if there are, other independent variables that might affect my dependent variable? Well, before you start exploring your data, you need to look at correlations first. These are the covariates. So you need to, if for example, um, in our example in this slide sets, that we are going to look at the dependent variable would be the bone mineral density. We know that bone mineral density, our bone gets stronger when we exercise, because when we exercise, especially when we do weights, um, exercise, gravity puts pressure, puts weight on the bone, and it makes the bone healthy. And for those who are in the space, like the astronauts, they really lose their bone density because they don't have gravity and they're just floating up in the air. And we know that in order for the bone to do a good osteoblast and osteoclastic balance, the bone forming versus the bone destroying cells, you need to have gravity, because the gravity puts the weight, and when there's weight on the bone, that's where normal bone functioning is. So we know that there is a relationship between bone mineral density and um, exercise. But what about if we think also that, hey, maybe those people who exercise also really eat fruits and vegetables? So how do we know if there's a confounders in our analysis? And so that's when we start thinking that way, we're now trying to look for confounders, and we will adjust for the confounders. And that's what you call analysis of covariance. But the requirement for this is that there has to be a correlation of this, of the dependent variable and your new hypothesis of alternate explanations for associations between dependent variable and independent variable. We cannot use ANCOVA when there's no correlation. Okay, it's like, it's wrong. You're never gonna get, it's the foundations of the concept of exploring the relationship is wrong, because if there's no correlations between the dependent variable and independent variable, why do you want to control for potential confounders? We already know that exercise is going to affect and will have a linear relationship with bone mineral density. The more you exercise, the stronger is going to be your bone. So the higher is the BMD. But before you think about, what about those who eat fruits and vegetables? Before you think that that's a confounder, you need to explore first whether there is a correlation, because you can only adjust for confounders or potential confounders. Like in our example here, the potential confounders are the people who eat fruits and vegetables. So what the ANCOVA is going to answer, that it will always have a two-sided hypothesis, and it will test the null hypothesis that there's no difference in means between the groups after controlling for the covariates or the confounding variable. And the alternative hypothesis is that there is a difference in the means between the groups after controlling for the covariates. So when you write for our exam, we still have group test 2, and then we will have our final exam. Always remember that when we do t-test, ANOVA, we have so many, we have one-way ANOVA, we have n-way ANOVA, we have repeated measures ANOVA, and then we have ANCOVA. All of this, you always think about your answer has to have means, okay? Because if I don't see the word means in your findings or your conclusion, then you did not get the concept that from all of this mathematics, it's parametric and it uses the means. So our statement of the findings and our statement of conclusion should be, there is a significant difference in the means. So that's the one that I will always look for. Did you put in your answer, in your conclusion, there is or there is no difference in the means between the groups after controlling for covariates. So that's, I want to really emphasize that t-test, ANOVA, ANCOVA, MANCOVA, I have to see the word means, because that's the foundational concepts, okay? And then for the alternative, for the non-parametrics, I need to see the word median and interquartile. So I need you to look again on the overview of the statistical function, that one pager that I already updated. It's important that you look at what are the parameters that are being used by the different statistics, so that when you report the findings, you use those words exactly, okay? So go back to this. The next one is, what type of research question can ANCOVA help to answer? Well, let's say we're interested in looking at the effect of exercise on bone mineral density. So we know that the bone mineral density is a measure of bone strength. Women are particularly affected. Women are definitely at risk for low bone mineral density because of their hormones, and also because they don't engage in a lot of physical and heavy athletic activities. But more, I think theoretically, women are really prone to osteoporosis because of their hormones. There's differences in our hormones biologically, where women are very prone to osteoporosis. So you'll see a lot of the fractures happening among women, more so than men at the later stage in life. So we know that that's already science, that's already existent, that the bone mineral density is a measure of bone strength, and a very good sample that we need to look at when it comes to studying bone mineral density will be women, because they are already what we call the target population. So in order to get a good understanding of what happens to the bone mineral density when there are so many independent variables that might affect the bone mineral density, it would be good to study the women in this regard. And then when we look at this, the other questions that we would like will be, how about if diets such as eating fruits and vegetables can also affect bone mineral density? And it is likely that people who exercise regularly also eat properly. So that's now your hypothesis now. What could be the covariance, or what could be a confounding variable in our study? So we will ask the question, how can we tell if exercise has an independent effect on BMD, on bone mineral density? So independent means it's not influenced by other variables, by other independent variables, or by other, well, we don't call them covariates until they they have collinearity. So we're trying to look at our model, whether is it really just exercise that will really be a strong determinant for higher bone mineral density. So that's basically our model. And then we're trying to refute that model, that it's so simple that when you exercise, you are gonna have a very good bone mineral density. So that's what I'm trying to bring home, is that we always question our existing model, our existing way of knowing, because we don't know what we don't know because we did not seek the truth. So always look for an alternative explanation. So we will use the following question to illustrate ANCOVA. What is the effect of regular exercise on bone mineral density once the consumption of fruits and vegetables are controlled for? So our dependent variable will be the bone mineral density. Our independent variable, or our factor, would be the exercise. Whether you we have two groups. One that's value, we put a value of 0 on SPSS. And this is the group that exercise 2 times per week. And then we also have the and then the other group that goes 3 times or more per week, and we will put a value of 1 on SPSS. Just like everything else, SPSS only talks to numbers. So when you look at your data, always make sure that everything is numbers. So we cannot put the word regular exercise or 2 times per week on SPSS, and we cannot put 3 times or more on SPSS. We need to have numeric. So we have to assign 0 and 1. And then for the covariates, we're going to look at the other independent variables in our data set. But for this example, I only built I actually painfully see this book from Monroe's Statistical. It's really meant for undergraduate students. And so every time they have a data set, they made the student plug in the numbers on SPSS. So I feel like I'm a student again. So that's why this is not one of my favorite. Unlike the book on regression by Dr. Osborne, where you go to a specific website, you can download this data that's already there for you. So, but for this book, Monroe's statistical procedures for research, for healthcare researches, it's really for the undergrad. And so every time there's an exercise, you are the one, but I did it for you. So I was very tempted to say, okay, class, plug in all this 100 variables and send it to me and we will analyze it together. It's like, nah, they're very busy. I'll just do it myself. So I plugged them all for you. It wasn't so bad, but I'm already 45, so I'm having presbyopia again. It's age-related changes where you lost the elasticity of your lens and there's a problem in accommodation and refraction. And so, mura kag malibat gamay magsigtanaos mga 0101 sa, excuse me, sa libro. Anyway, but I did it. And I beat the time. By 8 o'clock, I was really done. So that's good. All right, so these are some of the requirements for ANCOVA, is that the dependent variable is continuous. So ANCOVA cannot be equivalent to logistic regression, because logistic, the dependent variable is binary. Yes, no, yes, no. But the equivalent for ANCOVA is the multiple linear regression, because you have the continuous variables, and the independent variables, are the factors, are categorical. And then the covariate is continuous. So this is what we see and when we do a multiple linear regression. So the assumptions for ANCOVA are that the groups defined by the independent variables are mutually exclusive, that there is homogeneity of the variance, is again the Levene's test, that the dependent variable is normally distributed. So we're gonna check that, make sure that the bone mineral density has a normal distribution. And that the covariate and dependent variables have a linear relationship. So what does that mean? Well, we said that our potential covariate here is the consumption of fruits and vegetables, and that our dependent variable is the bone mineral density. So we have to do a correlation first, because that's an assumption for ANCOVA. So we have to do a correlation analysis of fruits and vegetables and BMD, and they must have a linear relationship. If they don't, there's no point in doing ANCOVA. You just violated the assumptions for ANCOVA. And the last assumptions for ANCOVA is that similar direction and strength of relationship between the covariate and the dependent variable in each group. So we will do all of that. So there's a 6-step procedure. State your hypothesis. We already did. There's no difference in bone mineral density when we control for produce or fruits and vegetables. And then we define the significance level. We make sure the data all meet the necessary assumptions. So we have to do the linear check, linear relationship check of the covariate and the dependent variable. And then we then compute the test statistics. Automatically, it will produce the standard and means and standard deviation. And then we determine the statistical significance and state our conclusion. So that's always very easy because we know that our statistical significance, our alpha level is always 0.05, and anything below 0.05 is statistically significant, and we reject the null hypothesis. Then we conclude that there is a significant relationship. So when there is statistical significance, we reject the null hypothesis. That means our alpha level is less than 0.05. So we illustrate the ANCOVA with the following question. Is the level of exercise related to bone mineral density in a group of healthy community-dwelling women once fruit and vegetable intake is controlled for? So this is our potential confounder. To answer this question, we will use the data from 100 women. We have the measures of the dependent variable, BMD, which is continuous, bone mineral density. So it meets the assumption of ANCOVA. And it has to be normally distributed, so we have to check the skewness. We have to look at the histogram with normal distribution curve and make sure it's not very flat. We're getting very good at this. This is now our second statistics class, so this should become very automatic to all of you that we need to make sure that we explore our data for normality. And we make sure, that the skewness is closer to 0. We tolerate minus 0.5 to plus 0.5 because we know that a perfect normally distributed data has a skewness of 0. So the higher positive number and the higher negative number, the negative number will be skewed to the left and the positive number would be skewed to the right. So the independent variable here is defined by the groups. We have 0 to 2 weeks, 2 times per week group, and the 3 times plus per week group. And we assign a value of 0 for the 0 to 2 times per week exercisers. And we assign 1 for the group that are called the 3 plus times per week exercisers. And the covariate is, of course, the number of servings of produce that they consume per day. So we have a categorical variable here, which is our exercise. And then we have a continuous, another independent variable that's continuous, and that's the number of produce, which is fruits and vegetables, that they consume per day. So we state our null hypothesis that the mean bone mineral density in the 2 exercise groups does not differ when controlling for produce consumption, because that's what this is all about, is we're looking for confounders, and we're trying to reject this null hypothesis. So we will say then that if we reject the null hypothesis, we will see that there is a difference in the mean bone mineral density in the 2 exercise group when controlling for produce consumption. So try to always exercise in your mind, if this is my null hypothesis and I reject this, I just remove the word no difference or does not differ. So my conclusion will be there is a difference in the mean bone mineral density in the 2 exercise group when I control for their produce consumption. And the alternative hypothesis is that the mean bone mineral density in the 2 exercise group does differ when controlling for produce consumption. And sometimes it's just very easy that when you reject the null hypothesis, then your conclusion, just state the alternative hypothesis. That's easy so that you don't make a mistake. That's my advice to you when you put your conclusion is, what's your alternative hypothesis? And if your p-value is less than 0.05, then use your alternative hypothesis as the conclusion for your study, the way exactly it is. So we define the significance level as always 0.05, which means we only allow 5% chance of error. And that's the 0.05 is the 5% is the critical value. And that's where we determine our significance level. And then we will obtain the exact p-value of the ANCOVA from the SPSS printout. So here is the printout. So one of the requirement for, or one of the assumption for ANCOVA is that this covariate is correlated and has a linear relationship with a dependent variable. So let's go to our SPSS. And here's my ANCOVA. Here's my exercise. It has two groups. The 1, 0 is actually, I said there don't exercise, but it says here, this is the group that exercised 2 times per week. And then this is the 3 times or more per week. I don't want to confuse you, so I have to follow what the book says. All right. And there you go, we can change. Okay. And then for bone mineral density, we don't have values because it's a continuous variable. And the produce, we also don't have a value because it's, again, a continuous independent variable. Those are the requirement. So in ANCOVA, our dependent variable has to be continuous, and our independent variable has to be one categorical and one is continuous. So when we look at our data view, here's our data, 0, 1, 0, 1 for those, for the variable about exercise, which is 2 times per week, and the other group is 3 times or more per week. And then here's our bone mineral density. It's continuous. It actually is a ratio type of scale. Same thing with produce. It's also ratio because we know that there's a 0 point. I mean, you either really don't eat, or you don't eat nothing with fruits and vegetables, and so you'll get 0. And so this is the serving. And so the first one is we have to check the assumptions. I have to better be quick. It's 8:28. I know I have 10 more minutes. Then we have a break. Analyze. We have to do a bivariate correlation. And we have to look at our assumption is that there is a linear relationship of the covariate with the dependent variable. So our covariate here is the produce right here. And our dependent variable is the bone mineral density. We check for options. You can report means and standards if you really want to know that. Continue. And then you do your Pearsons because we assume that this is normally distributed, which we will check after this. So here is our output. And what you see is that there is a linear relationship. It's statistically significant. It's 0.577 is the Pearson correlation coefficient with a statistical significant value because it's less than 0.01 level for two-tailed. So it's 0.000. So correlations has a very high significance level. It's 0.01 for two-tailed. You could do that as 0.05 for one-tailed, but that's a separate conversation. But let's assume now that we meet that assumption of ANCOVA. The next one is we have to see that our bone mineral density is normally distributed. So we'll look at means, we'll look at the skewness, we'll look at kurtosis, minimum, maximum, standard deviation. And the charts that we can check is always the histograms with normal curve. That's my warning for 10 minutes. And then we will take a break. We don't have to display the frequency table because I hate to look at that. And then we can always use the descending to ascending. We press OK. So right here, we know that the skewness of bone mineral density is 0.149. That's okay. It's good. The skewness for fruits is 0.5. As what I've said, minus 0.5 to plus 0.5 because our normal skewness is 0. We can tolerate that as a normally distributed. And right here, this is our bone mineral density with the normal distribution curve. It's a nice bell. And for our fruits and vegetables, it also has a nice bell curve. So by examination, I think we can safely say that our data is normally distributed. So we already check all the assumptions of ANOVA, and they meet those assumptions with ANCOVA. So we proceed then to the following slide. This is what we got. 0.577, it's statistically significant. You always get sort of a duplication because 1:1 correlation is a perfect correlation. So you have bone mineral density that's correlated to fruits and vegetables, and you have fruits and vegetables that's correlated to the bone mineral density. So pwede ra gud ni nga tangtangon na ning usa ka column, but di ta kabuot ang SPSS kay mo na iyang output jud. So next slide. And they have linear relationship. Kung gusto pa jud nimo nga i-check, understandable naman gina siya nga positive linear correlation. Kung type A jud ka nga pagkuan, statistician, you can actually create your scatter plot. Graphs, and then legacy dialog, and our scatter dot here. We always put our dependent variable in the y-axis, and then our produce and vegetable in the x-axis. And we press OK. And you can see here that there's our pretty linear relationship. You can see the direction is to the right, but to make sure, we will plug in the model of linear right here. And you know that that's the one that's being used right here. It's highlighting the linear relationship. So there you go. So we know it's a linear relationship. Let's wrap up this one. So we will have our 20 minutes break. And then, therefore, all the data meet all the assumptions. And this is the SPSS output once you run your ANCOVA. And right here, you will see that it's statistically, that exercise is already statistically significant. But you also want to see that the produce is also statistically significant to the bone mineral density. So that's why we need to check the interaction, and that is not statistically significant. And we look for the Levene's test of equality of variance, and it passes that assumption because it's 0.378. So we cannot reject the null hypothesis that there is no difference in the error variance of the dependent variable across groups. So that's good. We don't want the Levene's test to be statistically significant. And then we compute the value of the t-test statistics. And here, the bone mineral density by exercise group, this one, by exercise, and bone mineral density is 0.02. And that is statistically significant when we control for the produce, because we included that in our full model. So therefore then, we can state that after adjusting for produce consumption, the mean bone mineral density among women who exercise less than 3 times a week is 0.769, and among women who exercise 3 times per week, 3 times plus per week, it is 0.886. This difference in the mean bone mineral density after adjusting for produce consumption is statistically significant, and the alpha level is at 0.05 level with a p-value of 0.023. So although the interaction was not significant, we know that once you adjust for the confounder, we control for the confounding about how many produce they consume a day. We know that between the groups of exercisers, that the mean score of the bone mineral density is statistically significant among women for these two groups of exercisers. It's 8:36. I probably have 4 minutes, so let's do the ANCOVA on SPSS. So we analyze general linear model, we do univariate, and that's already there. And our model is full factorial, and we just plug that in. And this is exactly the output that we see on SPSS. Right here. The produce was significant, exercise was significant, the interaction was not significant. But then we do the second one where we do the univariate, and then we put the produce let me reset this one. Dependent variables exercise. No, wrong. That's not correct. Our bone mineral density is the dependent variable. Our exercise grouping is the fixed factor, and our covariate is this. And we plug in the model, and again, full factorial. And we say, okay. And we want to see how does that look. And so right here, we can see that it's 0.02. That this two groups of exercisers, the women who exercise 2 times per week and women who exercise 3 times or more per week, had a statistically significant difference in the dependent variable, which is your bone mineral density. All right. Awesome. This is recorded, and I will email you the slide set. And then now we're going to go to Cohen's D, and we are going to do factor analysis. And I hope that you've watched my video on theory and measure, because that's really very important when we do our factor analysis. All right. I'll see you in 22 minutes, 9 p.m. Okay. 9 p.m. my time. It's 11 a.m. your time. All right. Bye, class. Enjoy the break.